Hi everyone, welcome back. I'm glad that some of you have made it to the second assignment and haven't completely given up on R yet. As I mentioned in the last video, my name is Tim, and I'm going to help you traverse some of these difficult initial commands. So first we're going to set our working directory, and we're going to set it to the folder in which we have our dataset. Now remember, the dataset is ANES328.CSV. If you don't have that, quickly pause the video and go acquire it from the Moodle page or wherever it was provided for. What you're going to want to enter here is the file path for the directory in which you have that saved. So in my case, I have it saved in my Dropbox in a folder called RLessons and in a subfolder called Lesson 2. You can quickly go check this actually by right-clicking on the file, clicking Properties, and it'll show you this file path. If you're on a PC, you're going to want to change these to // On a Mac, you can do the same thing but click Get Info. So let's put our cursor there and Control Enter, and our working directory is set. Now let's use the read CSV command that we learned last week to assign the dataset to an object called dataset. And if all went well, it should be up here in the top right. Again, feel free to pause the video if you need to take time to make sure that that was arranged properly. So let's start inspecting and cleaning the dataset that we just read. First, we can look at the number of rows. So on line 16, we notice that there's 47,438 rows. On line 19, we can check the number of columns. There are 13. This information is actually evident in the environment in the top right pane. You can see that there's a number of observations of a given number of variables. You could also use the dim command on the dataset to get both of those figures, the rows coming first. Now, we may be curious about the names of the variables because we need to use them in commands so that we can manipulate them properly. So let's just check those out very quickly. As you'll see, this was a survey. If you didn't get any information on the ANES, I recommend that you go check it out. But as is typical of large surveys, they name their variables in inconvenient ways. And so what we're going to need to do is actually reassign values to the names variable for this data set so that our variables take on more understandable names. So what I did is I went into the codebook and I found what each of these represents. And in the order that they appear when I call the names, I replace them in this string here, and I'm assigning it to the names of the data set. Okay? So here we have ID, gender, all the children variables, whether they're married, their political interests, and their partisanship, as well as how often they discuss it. So let's quickly run that, and then we'll check the names command, and we'll see that they're actually what we just renamed them. Finally, we may be interested in whether these data are in the correct class of object, or what class of object these data are. So we can use the str, the structure command that we learned last week, and Control Enter, and pardon my screen here. As you can see, we have some that are integers and some that are characters, and so we're going to have to use that information to deal with this. We can call the head command to see the first 10 observations. I have that specified here, but by default it's 10. You can change that number. And as you can see, we're actually missing a lot of data for these variables, so we're going to need to deal with it as well. So let's move on to step 3 and check the data consistency. We can use a logical operator called is.na on any of the variables in the dataset. Remember, we call a variable with a $sign after the dataset name. So we're looking at the variable disk_qual5, and we're curious as to how many of these are missing, or NA values in the dataset. So let's click Command Enter on line 39, and you'll see that you get a whole slew of logical vectors, true or false. Now this will come out true if any row that it's pinged, there's as many true and false reports here as there are rows in the dataset. It's true if the row that's being pinged is an NA value, and it's false if it's not. Now we can actually run a sum on the output of a logical operator. It'll treat trues as 1 and false as 0. So you'll see that I have sum and a nested function. It's the same function that we just called up there, the is_na, the dataset disk_qual5. But now we're summing the results. And we have a nice clean number, 35,717 of the disk_qual5 column are missing values. Now we can also negate a function, a logical function, with the exclamation point in front. So if we quickly run this subset of the command, exclamation point is a dataset disk_qual5. We'll get a similarly overwhelming report, but it's going to be the negation. So it's looking for rows where it is not an NA. So we'll report false if the row is an NA, and it'll report true if it's not. And again, we can run the sum command, and we'll see that we have exactly 11,721 rows in which the disk_qual5 column is not an NA value, meaning we have a meaningful. So now that we've done some inspection, you can extrapolate those methods to look at other variables in the data set. We can start getting some basic data summaries and statistics. So maybe we're curious about the gender breakdown of the response. We can use the same logical operator and the summing of the logical operator that we just learned, but we need to be a little cautious. So let's quickly check the gender column for all of its unique values on line 49, and we'll see that we have male and female as well as an NA value, meaning that there are some missing data. So let's say that we're curious as to how many reported as female. We can actually just quickly run this subset of the line, and again we'll get an overwhelming response of trues, falses, and some NAs. And if we sum this, we can quickly get the sum, but if we don't include this little function here after a comma, NARM equals true, the sum will just be NA. So if we include this, it'll just sum up the non-NA results from that logical operator. So it looks like we have 26,317 respondents who are female, and we have 21,018 that were male. So we're curious about partisanship. Again, we can repeat the step that we took earlier and get the unique values in here. And it seems like we have many more. And say we were trying to take maybe the median mode, mean value of this column. We can't quite run that operation on character string because R doesn't know how to run the average of characters. So what we're going to need to do is recode this column into a new one. So we're going to create a new column called dataset party7 recode. What we're going to do is first we're going to assign, with that little operator there, just the entire column from party7. Right? This way we can retain the original data in the party7 column and then manipulate it how we want in the recode column without losing anything. So let's quickly run that, and you'll see that we now have another column in there called party7 recode. Now we're going to use the which function that we learned last week to run an operation on subsets of this column. So we're going to assign the value 7, see that over here, this is on the other end of our assignment operator, to the party7 recode column, but only in instances where the party7 recode column is strong Republican. Okay? And so by running this line on 58, we're taking all rows in which the data7 party recode column is exactly strong Republican as we have it recorded here, and we're changing that to the number 7. Now we're going to do that for weak Republican to 6, independent Republican to 5, completely independent respondents to 4. We're going to turn independent Democrats to the number 3, weak Democrats to 2, and strong Democrats to 1. And for our purposes, apolitical respondents, especially because it was only a specific subset of the survey, are just not of interest. And so we're going to recode those as NA. You can see that over here. And we're going to consider them missing data for our purposes. Right? And finally, on line 67, we're running an asNumeric command to make sure that those numbers are actually treated as numbers. This isn't something that you always need to do, but it's a good fail-safe to make sure that you do it. So let's quickly get a peek at this new column that we've created with numbers instead of categorical variables. We can run the table command to get the individual discrete frequency of each value in the column. So we'll see that there's 8,700 and some respondents who were, well, let's recall, what did we code as one? Strong Democrats. Whereas there are 5,300 and some who were strong Republicans. And it looks like about 4,900 and a few who were completely independent, or at least is suggested as such. Now we can assign this function that we just ran to a variable. We'll call it tab, for example. Run that line, you'll see that you have a value called tab, and that contains what we just ran. So if we run just that, you can see down here, that's the same thing as when you run the table command. Now you notice that in some cases I'm highlighting just a portion of the text and then hitting Control-Enter. You can do that to run just the highlighted portion of code from your script up here. Just make sure that you highlight what it is you want to run. Now we can also run a function called prop table. This will give us the proportion frequency of each of the responses. And we can run that on the variable that we just created, tab, because we have to run that on a table variable. So let's check this out. It looks like about 19% of the non-NA responses were strong Democrats, and about 11% of the non-NA were strong Republicans, with about just shy of 11% as complete independents. Now you notice if we nest these functions, we actually get the same exact result. Because remember, the tab object is just the assignment of this table function that I've highlighted here. So if I run that, we get the exact same thing. Now, let's try to get the average score. Remember, the mean function is how we get the arithmetic mean of a given string of data. And so we're going to run that on the party7 recode column, and we're going to remember to exclude the NAs, because otherwise we're just going to get an NA result. When we run this, we see that the average numeric score is 3.61, which is just below 4, so it does. Sorry about that, folks. As I mentioned, when we ran the mean, we got the result of 3.61, and we can see that that skews toward Democrats, which are the lower values in the data set. Now, there are a whole slew of other summary statistics we can run. Some of these we covered last week. So the length command, for example, gives you the number of variables in a given object. Sorry, not variables, but values. So in this case, it's going to be the same as the number of rows in the data set because every column has the same number of values as every other column. We can get the minimum value, which we know is 1 because we just recoded that column. We can get the maximum, which we know is 7. We can also get the range, which will give us both the minimum and the maximum. We both know those are 7. Now notice that I have NARM equals true in here because it's important that we have that, otherwise we're just going to get NA results. We can also get the median to check against the mean. It looks like it's 3, so it's a little bit under the mean, so we can get an idea of where the skew is in the distribution. We can also run the quantile command. Now this one's a little bit more complicated, so let's unpack it a bit. When you run the quantile command, the first thing you enter is an object of numerical values. So again, if we just highlight this and run it, we see that there's some NAs here, which is why we have NARM equals true at the end, but a whole slew of them are numbers, just like we suggested they should be. Next, you enter a command called probs, and then you enter a string. So in this case, I have 0.25, 0.5, 0.75, and 4. What the quantile command is going to do, and I can demonstrate this as I'm describing it to you, is it's going to give you the value at which 50% or 25% of the data is at or below, right? So in this case, 75% of the data in this column have the value 6 or lower. Half of them have the value 3 or lower, a quarter of them have the value 2 or lower. Now we can change this and introduce other probabilities. It doesn't have to just be the one that I gave. And we'll see that at 10% of the data or lower has a value 1. So hits the floor there. Remember to save your script whenever to save your edit. Now we can run a summary command, which actually subsumes a lot of these other basic commands that I showed you. It gives you the minimum value, the median, the mean, the max, the number of NAs. It also gives you the first quartile, and the third quartile, which are the 25% and 75% respectively. The summary command is really helpful because it gives you just a broad range of summary statistics on the data that you're looking at. Finally, we can get the variance of the data set, which looks to be about 4.32. And the variance helps us to build up to the standard deviation. So you'll notice I can run the standard deviation command, which is just SD on that, and keep the NARM equals true in there. And we'll get the standard deviation is about 2.08, which is the same as the square root of the variance. Okay, so the standard deviation can subsume the command if you like it, but you can always nest functions to get what it is that you want. Let's move on to the next step, which includes creating new variables with clean and inspected data. So let's say we're curious about how many people were married. We can look at the marital column and get the unique values, and we'll see that these are again character strings, so it doesn't look like we have numbers for this. So we're going to need to use a logical operator to identify the rows in which a given respondent was married. So let's unpack this next command on line 97 a little bit. You'll notice here that I'm creating a new column called marital binary, and I'm using the equal sign to equate it. You can use that in place of the caret and the hyphen. I usually recommend that you use the caret and the hyphen because that's a directional assignment. This is a literal equation, meaning that the two are equal, and it assigns in both directions. Now the result here is we're using a logical operator, the double equal sign here, to test if the dataset marital column is exactly equal to this value. Okay, because this is the value that we're curious about. The rest of them have to do with not being. So let's see. If I just run that logical operator, we'll again get an overwhelming amount of trues, falses, and NAs. But if I run this to assign it to a new column, we won't get that response. Rather, it's all going to be stored in a new column. So if we run the unique function on that to get the unique values within there, we'll see that we have NAs, true, and false, which is just what we hoped. If we run the sum function, we can get an idea of how many respondents were married. Precisely 28,756. Okay, let's move on to children. Say we're curious about how many individuals had children under the age of 18 and how many they had. Let's look at all of the relevant child columns, and let's look at the unique values that they each have. Okay. So it looks like a lot of these are numeric, and we have NA values in basically all of them. So, say we're curious as to whether these columns, child 17, 13, 9, and 6, equal this column when they're all added up. Well, we can use the row sums function, which I have on line 110, and run it on all of them. But what I'm going to do is show you a shortcut. We're going to create an object called child columns, in which we're going to put the names of the columns that we want to sum up. You'll see that that shows up here when we run that command. And if I call child columns in the console down here, it'll spit out those names, which is awesome and great. Now, we're going to run the row sum command, and we're going to assign the output of the row sum commands to a new column that we're creating called child sum. Okay? So the row sums command will take the sum of each row for the columns that you specify. Remember, when we specify within brackets, we put the columns after the column, and the rows go before. So if we look at dataset child columns, we'll get the response for all of the columns for each row. Okay, a lot of NA values here. Now, if we run the row sums command, we'll just get one string, and that's the sum for all 4 of those columns for each row. Now we're going to assign that to the new column, child sum, and we'll see that we get the exact same thing as if we run the row sums function because we assigned it to it. Let's quickly check the summary for each of these. The summary for the child sum shows us that there's a great deal of people who don't have very many at all. Whereas the summary for the children variable shows us that there's actually a higher proportion who do have children. There's a higher median, a higher mean, higher third quartile, higher, actually a lower maximum, and a much higher number of NA values. Let's quickly run the table function for each of these to get an idea for the spread of the data. Looks like they're actually quite similar. Oh, my apologies, folks. I ran that on the same column twice. So if we run that on these separate columns, with the prop table function, we can actually get the proportion of non-NA responses. Specifically, in the children column, which is not the one that we created, there are 26% of people who don't have any. You'll notice that it spits out sometimes difficult to interpret values for the prop table when they're very low values. You can always identify these within the data. Say you wanted to assign this to the tab value. Again, remember that's going to overwrite that. But we can call on the tab function, the tab object, and it'll spit out the same thing. And say we only want the first item in the tab object. That's 0. Okay, so how many people had 0 people? 0 children, and that's 61%. Now finally, let's take a look at the variables on political interest. First, let's get an idea on the first one, the Holland. We get the class of that, and we know that it's a character. We get the unique values. We can see that there's NA values in there somewhere. And then they could have responded with very much interested, somewhat interested, not much interested, and DK, which we have to assume means don't know. Unfortunately, we're not very concerned with the DK values, so we're going to do what we did earlier and assign an NA value using the which function to identify the subset in this column, which are DKs. We're going to turn them all to NA. Okay. Let's go to line 130, and we can get a table of how often each of these shows up. You'll see that we don't have the DK function in here, value in here anymore, because we got rid of it by assigning NA to all of them. And there's 11,500 people who responded as not much interested to this question. There's about just shy of 19,000 who said they were somewhat interested, and just over 13,000 who said they were very much interested. If we're curious about the proportions, we can again run the nested function with the prop table. And we'll see that the spread is presented in percentages. So we have 26% of people not very interested, 43 somewhat interested, and about 30% who are very much interested. Importantly, these add up to 100%. Again, it's excluding the NA values. Now we can use those logical operators with the same unique values in other columns. So let's look at the other political interest columns. So column B, for example. Look at the class, it's also a character. The unique values are different though. So there's NA, care a good deal, and don't care very much, don't know, pro, con, depends, and other. Kind of a wide range of responses. So let's get a table for all of these. See that about 17,000 people care a good deal, whereas about 8,500 fall under that much broader category. We can run the proportion table to get the spread. Again, this excludes all NAs, because if we add this up, the 8,500 and the 17,000, we do not get the 47,000, meaning there's a significant number of missing variables in this. Sorry, missing values. And we can do the same thing with the column C column, and we'll notice that there are significantly more response options. Let's quickly omit the DK column. So let's type this out as we do it. Dataset, call int C, which dataset, call int C, equal DK, and we're going to just assign the NA value to that. Okay, see how quick and easy and painless that was? We can just quickly run that. And now we run the table, and again we'll see that we don't have the DK, but we have numbers for how often each of these was responded, and then we can get the. Okay, and if you didn't catch that, we were able to just tabulate the frequency both in terms of discrete responses and proportions of responses that are non-NA values for each of these political interest columns. And we were able to ascertain that about 36.5% of the people responded with some of the time in the Paula and C column. These are all spat out in the console here, and you can use those to answer any questions that might be asked about the data set. Now, if you're curious about what explains the differences in these columns, it would be important to reference the codebook. The codebook is a very important resource for using survey data because it explains the questions that were asked for all of the relevant columns, the time frame in which they were asked, which might explain why there are NA values, and the nature of the data that's being stored in there. Okay, so I'd highly recommend that you check out the codebook for the ANES dataset. It should have been provided to you. And this week we didn't cover visualizations, but you can certainly take some of the code from last week and run some scatter plots or histograms on bivariate or univariate distributional analysis to get an idea or a feel for the data. Again, the commands are hist for histogram and plot for the scatter plot. You can check back to the first script on that. And you can do some bivariate cross tabulations if you're really interested. I understand that this may be extra credit for the assignment. So I've provided some links here. Feel free to take the time to look through those if you have the script, or pause the video now and you can type it into the browser. I even included a YouTube video. Anyway, I hope this was very helpful for you folks, and I look forward to speaking with you again.